This is Interstellar News Broadcast, and today we present one of the most significant scientific developments of our time. An object from another star system, officially classified as 3I Atlas, has been confirmed to be leaking water while passing through our solar system. To understand the magnitude of this discovery, we must first look back at the moment when humanity realized that objects from other star systems were not fantasy. They were real, and they were passing right beside us. Until 2017, astronomers had never confirmed the passage of any body originating from outside the solar system. Every comet and asteroid ever documented was gravitationally bound to the Sun. Some came from distant reservoirs such as the Oort cloud, but still they belong to our system. That changed in October 2017, when telescopes detected an object with an orbit unlike anything seen before. It moved too fast to be captured by the Sun. Its trajectory was open, hyperbolic, and its name was 1I Oumuamua. Oumuamua puzzled the entire world. It had no visible tail like a comet, and yet it sped up slightly as it moved away from the Sun, behavior consistent with gas release. Its shape was elongated, unusual, almost blade-like. Some scientists said it was a fragment of rock from another planetary system. Others proposed exotic theories, including artificial origin. Whatever it was, it came and went, leaving behind uncertainty. 2 years later, in 2019, the scientific world was stunned again. Another foreign visitor entered our system, 2I Borisov, but this time it was unmistakably a comet, with coma, tail, and clear activity. It behaved just like the comets we know, except it was not one of ours. It came from elsewhere. That confirmed an extraordinary truth. Comets are not unique to our solar system. Other stars also produce icy bodies. Then in 2024, a third visitor was detected, 3I Atlas, discovered by the Atlas Sky Survey System in Hawaii. Its hyperbolic orbit confirmed beyond doubt. This object was not born here. It is a foreign traveler, passing through on a cosmic journey that began light years away. But what happened next was even more remarkable. Astronomers directed NASA's Swift Space Telescope toward 3I Atlas. Swift operates in the ultraviolet spectrum, a range of light that Earth's atmosphere blocks, meaning these observations can only be made from space. When water ice in space is exposed to sunlight, it breaks apart into hydrogen and hydroxyl, OH. Hydroxyl emits a very specific ultraviolet signature. Swift detected that signature coming directly from 3I Atlas. There was no ambiguity, no speculation, no room for sensationalism. 3I Atlas is actively releasing water. The estimated rate? 40 kilograms per second. To visualize, that is equivalent to a high-pressure firefighting hose blasting non-stop into space. It is enough to fill a household water tank in mere seconds. It is more water loss per minute than the average human uses in an entire day. What makes this even more scientifically shocking is where this activity was. Detected 3I Atlas was leaking water at a distance of 3 astronomical units, 3 times the distance between the Earth and the Sun. At that distance, most comets from our own solar system remain dormant, too cold to sublimate, but 3I Atlas was already active. This implies that its chemical composition is more volatile than most local comets. Its ice is likely less compacted or more exposed. It may contain different kinds of frozen materials, formed under different stellar conditions. This is the first confirmed case of water activity in an interstellar object measured while it was still far from the Sun. The confirmation of water activity on 3I Atlas is more than an astronomical curiosity. It is a breakthrough in comparative planetary science. For the first time in history, scientists can directly compare the behavior of comets formed around other stars with those formed around our Sun. This allows researchers to evaluate how common water is in other planetary systems, measure how early or late comets become active depending on their composition, understand whether icy bodies elsewhere are richer or poorer in volatile materials, estimate how planetary systems evolve chemically beyond our own water. Is not merely a molecule, it is a scientific tool. Astronomers use water sublimation rates to estimate surface composition, measure energy absorption from sunlight, track rotation and surface disruption over time. By applying these same metrics to 3I Atlas, scientists can now rank interstellar comets on the same scale as solar system comets, And this leads to an even deeper question. If water is common in interstellar objects, how common is organic material? Previous missions, such as Rosetta at Comet 67P, confirmed that local comets contain complex organic molecules. If future observations detect even traces of such compounds on 3I Atlas or future interstellar comets, then we may be looking at the building blocks of life, traveling between star systems, not as fiction, not as theory, but as data. This does not prove life exists elsewhere, but it strongly suggests that the chemistry required for life is not unique to our solar system. At the present moment, the interstellar object 3I Atlas cannot be observed from Earth. This is not due to secrecy, classified tracking, or data suppression by any agency. The reason is entirely geometrical and predictable. After passing near the orbit of Mars, the comet positioned itself on the opposite side of the Sun relative to Earth. In astronomy, this phenomenon is known as solar conjunction. When an object is in conjunction, the Sun's glare completely overwhelms any attempt to monitor it, whether through ground-based telescopes or even most space-based instruments. No telescope, no matter how advanced, can safely aim through the solar disk to capture a faint icy body hidden behind it. For safety reasons, such observations are halted until the object re-emerges. This waiting period is standard protocol in scientific observation. It does not indicate the end of the study. It marks a pause before a more crucial phase. Once 3I Atlas becomes visible again, astronomers across multiple observatories already have a clear and coordinated objective: to compare its level of activity before and after its closest passage to the Sun, known as perihelion. The water emission detected earlier, estimated at 40 kilograms per second, occurred when the comet was still 3 astronomical units away, 3 times the distance between Earth and the Sun. At that range, most comets from our solar system remain inactive, too cold for water ice to sublimate. Yet 3I Atlas was already expelling vapor. This means that the first recorded phase of activity is documented. What scientists do not yet know, and must now determine, is whether the rate of water release will increase proportionally as it warms further. Other volatile compounds will emerge as different temperature thresholds are crossed. The comet's nucleus will remain structurally stable or begin to shed fragments as stress from solar heating intensifies. These questions do not require speculation. They require repeat measurement. There is no need for hypothetical missions or futuristic concepts. The continuation of the investigation depends on a very simple and reliable procedure. Observe the comet again when it comes back into view. Compare its current state with earlier data, and analyze how much it changed. Until that moment arrives, a central fact remains solid and scientifically verified. For the first time in human history, astronomers have directly observed water being released by an object that originated from another star system. Not inferred, not theorized. Detected, measured, confirmed. This is not a statement of imagination or belief. It is a recorded physical event, witnessed through ultraviolet spectroscopy by a space-based instrument, even if no further discoveries were made, even if the comet were never observed again. This one result alone would already stand as a milestone in planetary science. It proves that water ice exists and becomes active beyond the realm of our Sun. It demonstrates that the mechanisms governing cometary behavior are not unique to our solar system. It confirms that icy bodies formed around distant stars travel freely through interstellar space, occasionally entering the domain of others, including ours. What awaits next is not speculation. It is simply continuation.